Are you bored of HTTP protocol? I do have my protocol for you. So let's discuss what is my protocol and where it sits. So if you are familiar with OSI model, which is actually a model to represent the whole network, which is says that the network is divided into 7 layers, out of which these 3 layers can be combined together and said that it is application, like it's part of the application thing. And then there is this physical layer, which is like a physical device, and then there is the data link layer, which tells you how to communicate between two devices. Then if you communicate between multiple devices using hops and things, and if you want to abstract this thing, for that you have the network layer. And once you reach to a computer, and in that computer, if you want to know which application you want to go to, with that you have the ports, and that's where the transport layer sits. So network layer have the IP address, transport layer have the port, and our protocol sits just above this. Here it is where the HTTP protocol works, and we are making our own protocol, which is my protocol, and it sits between this. So let's discuss what is like structure of the request and response we will be using. The request will have one byte for reserved for the method, which is like get, put, post, and then there is this path length. Why path length? Because how we will determine the what is the number of bytes we need to read for the path. There might be another way to deal with this kind of thing, is having a null byte at the end. But for my case, just for simplicity, instead of doing too much of my thinking, like too much of my work, I just used it path length up here. So it's like a 4 byte of path length. Then based on the path length, there is this path. Then there is the 4 byte of body length, and based on the body length, there is this body. Moving forward, there is also a response. The response have 2 bytes for the status like 200, 400, which all this we have seen in the HTTP protocol, found, not found, success, failure, like that. Then there is the 4 byte for length, just as we have in the request, and then there is the body. So that's how our input and output data, like request and response, would be adjusted. And this protocol actually works on a client server architecture. That's why we have a response and a request. So let me show you it in action. Let me show this to you in action. So up here, I just start my server. The server is up, and now I can use the client to make some kind of request. Like up here, I have made a Redis server, like which is not exactly the Redis server, but a key value pair database to store it, the key value pair data in the memory. And up here we have the thing, the client, we can call it on the key where kv store and the key and value, and it stores the thing. Then I can get it. I can get it like of this, and even I have the put you, yeah, up here. This will update the value, and then we have the get. That's how the thing is laid out. So on surface, I'll show you the code. On surface, how it is working is, on surface what you have to do is, you have to make a instance of my protocol server, then configure the routes, and then start the server. Okay, that's simple. And in the configure route, it is like having a hash map. I do have a hash map. I've used like a little bit of uh, polymorphism just to make things very fancy. The thing would have been done without all these things also, but just to have things a little fancy, I use polymorphism. Up here there is a map and store, and you can like get the things and store and get it out. The handler function look like this. There is a response coming out, there is a request, and that request have things like get body and get metadata matches, like those kind of things, and that all fits up here. So how exactly is this server working? Because that's the most important part of it. To do like to open a TCP connection in Linux based system, the server is like designed specific for the Linux based system. What you have to do is first you need to bind a port. Okay, first you need to bind a port, then you will configure it, then you will like listen, accept. Actually, I think configuration part was done for it. Let me check it up here. In this whole thing, we have like our server sitting in a library which is like separate from the main app, which is a Redis server. And in this we have this TCP socket which actually handles the TCP socket. And in TCP socket we have the constructor which actually configures the whole thing. So first we need to configure it. Then after configuring we need to bind it, and after binding we need to listen on the port. Okay, and while we are listening to the port we can accept a connection. Okay, we can accept a connection. So that's the whole thing. That's simple, we have done it. So that's how the whole thing is going. First you need to configure, then bind and accept. And in Linux system, whenever you start a socket, it gives you a FD, file descriptor. Okay, and FD is just like a ID, a number, an integer value, which just tells you that this socket has this particular ID and you can use it. One thing which I have done up here is, which is interesting, if rest of things are like just copy paste thing, which you have to do to open a TCP connection. Okay, like this port, you can take the port, this IP address, you can take the IP address, then you need to convert and things like that. Then there is this socket being open like start, and then you get the FD, and then you have the set socket options and things like that. One thing is this, you can set a file descriptor to be non-blocking. That means if you do some operation like accepting a connection to a file descriptor which is not which is like blocking for now, it will block and it will wait for the connection to come. Otherwise, if you make it non-blocking, then it will fail. Like it will give a error message, and it will like not block the whole system. Either it will get a connection or it will just won't get and give a message, error message, which you can like e again up here. E again, you get a error number which you can match, and that is like E again. And then if there is like no connection available, you can say that there is no connection available. And up here we use optional type, so I can use null equity. So that's how a connection is being established. Let's come to the server. What is happening up here? So in the server we have this start function. This start function calls the event loop. Okay, and what does the event loop do? Let me show what is a event loop. Event loop is a loop, like simply a loop, like for loop, while loop, the loop you think of. And that loop will perform some kind of sequence of non-blocking operations. It will store the state of anything like request. If it is complete, then it will wait for the next cycle and perform some other operation on the request. And if it is not complete, it will just read it like pending, done, is ready, and pending, like that. That's the whole thing. You can check up here. First we do accept a connection. Yeah, I do accept a connection here. We saw socket accept connection function just now. Then in this handle request, then we have this handle request, and there is like add response and things like that. So the what does this handle request does is, if a request is not ready, then it will read it. Simple read. I'll show you the read function in a while. And if it is ready, then it will just call a response handler for that. And what is and where is that response handler being called? In this function. And how it is being called? It is being called from a hash map. The hash map is up here, which actually have the function being stored with a key, and key is method and the route. Like that's what you need to find what action has to be taken, isn't it? Then there is this response handler being called, and once the response is made, like created, or response is created, then it is pushed into the responses. And then we have this another loop. Now this part is done, then you need to write to the response. Then we have this write function, and we have else. If like write is done, then we erase it from the responses, which is up here, and then the whole cycle repeats. Like it goes and goes and goes and goes. So one thing you might be like a little bit wondering, what does this slip up doing up here? Why not just do it in a very frequent way? Well, you can do it in a very frequent way, but if you like spin the thing and like spin a loop with nothing stopping it, then it will take lots of CPU cycle and make the CPU very busy, which will show it on your graph if you don't have it. So that's why we have it. Now let's check this read function. What does this read function do? Where is it first of all? Read function is in request class. This is the request class, and this request class have these few functions. Read is ready. Few of the getters. This is for comparing. This is for like comparing equal to operator, and not comparing, actually assigning. This is for assigning. Okay, up here you can see. So this is like assigning. Okay, and these are like get connection and request. So up here we have these things: the method, the route, like length, the route, the body, things which we saw before. Then we have this method which is like taking just integers, like let's say num, you know how num works in C++. And then we have this type defined, and that's the overall thing. What does is ready do? Is ready will check this read length. Read length is how many bytes have been read till now in this request. For example, if there is this whole request, if the whole data read in one cycle is this much, then it will contain the number of bytes till now, till this one only. So if number of bytes read is greater than or equal to total number of bytes which we have to read, then the request is ready, isn't it? That's what we want. That's what we want. That's the whole thing. Then we have this read function. Hmm. What does this read do? This read called the read blocking, non-blocking. And this read non-blocking, it's not, it's like very simple thing. There is just a syscall coming going on. Uh, this read syscall, which actually reads the data to a buffer of certain size. We could read some number of bytes. Okay, and if the byte is greatly smaller than this, then there could be some error. And with that, if it is E again, then you just say nothing. Otherwise, you say that this error happened, or otherwise, you just if like read is successful, then you just resize it and give it back. And we'll see the write here too. Like there is a write, and these things are actually non-blocking. Like this connection, like Once you accept a connection, you get a connection. And this connection also have a file descriptor, a separate file descriptor. So every each and every connection have their own file descriptors. Okay, so that's how read will happen. Let's come back. There is a read happening. Then if read is like empty, nothing is read, then go back, continue with the loop. We have this loop. If we remember the event loop, if we have something read, then in this part we just check that if the length of, if nothing is read, then there must be something, like there is, if there is at least one byte and we have nothing read, then first byte must be a method. That's what we are doing up here. We are casting it to the first byte to the method, which is actually uint8, like 8 bit, which is 1 byte, and then we just increment the read length and just trim the vector. Then we go for the second thing, which was in here, path length. So path length is being made here, and this is a very cool thing. This is a very cool thing up here. So like second field is 4 byte long. There can be a chance that the 4 byte long thing might be read in parts. Okay, parts. For example, in the first loop, we got only 1 byte. In the first loop, we got only 1 byte. In the second loop, we got another byte. Now we need to add both of these. How we will add? We will use a shift operation up here. We use a shift operation and we shift the byte. Now the second one looks like this. Now what we do is we will OR it, OR operation just adds the thing, like 1 1 becomes 1 1 0 becomes 1, like 0 0 becomes 0, otherwise everything becomes 1. So that's the OR operation, and this actually moves, shifts and pats it. So that's how the thing will be, and we will do it byte by byte until we just finish it. If everything goes well, then we can just say that the thing is done. Then we have this field for path being read. It uses the same technique of skip, and since it is a character array, it is very easy to visualize, and that's it, simple. There is a buffer being read, and it's like that. Same way we do it for the body length and body. Once the whole request is being read, once the whole request is being read, then the response handler is being called. The response handler have that function we saw up here. And what is happening in this response handler? Like after response handler, how the response is being written. That part is actually in event loop up here, and this is in here. So we have the write function, we have the status, body length, body, and just like last time we had the read length, we have the written length here. And with that, what we do is we go and write. The write function up here have like, if it is already written, then return. Otherwise, make a vector, copy the status in the first byte, then copy the length in the next 4 bytes, then copy the whole body, and then like with a non-blocking write, try to write whatever number of bytes have been written, add it to byte length written, and then just return. That's it. And with this, the whole thing works. And isn't that cool? Isn't that cool? It works like, it's here. You can, I do have, you can delete. This deletes it. Now if you get, it will say that key not found. Well, that's all for today. Thank you.